Here we are doing special IVs. And if you notice that I wrote at the top of the study guide here, if I can ever get it up there, special IVs, critical care, and pediatrics all use 60 drops per ml tubing. That is because these are highly concentrated. We don't want the patient to get any more than what they are supposed to be. So when we're talking about special IVs, we're talking about things that may be done in units, such as heparin or insulin. So we're going to go to the first one, and we're looking at heparin 30,000 units, and I know I should have spelled out units, in 200 mLs of D5W, and we're going to run this continuously at 1,500 units per hour. So first of all, we're looking for milliliters per hour. And because we're looking for milliliters, we need to put the 200 mLs on top of the 30,000 units. And our another conversion factor is 1,500 units per hour. So we can get rid of our units, and all we have left is milliliters per hour. So can we reduce this down any further? Well, yes, we can. We can get rid of these two zeros there. We can get rid of the other two, right there. So now all we have is 2 times 15, which is 30, divided by 3, 10 mLs per hour. What I like to tell students is always reduce down as far as you possibly can, because then you're getting into large numbers and you may not put enough zeros there in your problem, and you're going to come up with something different. Either you're not going to give the patient enough, or you're going to give them too much. So now we're looking at volume per minute. So that means we're looking for drops per minute. And we just set it up the same way. 200 mLs over 30,000 units. And we're going to run it at 1,500 milliliters per hour. 1,500 units. And now we have to put our drop factor in here, which is 60 drops per ml. So we can narrow this down to, we can get rid of these zeros, get rid of these, or get rid of all these zeros there. Now 3 will go into 60, or 3 will go into 15. One time, it will go over here 5 times. I think that's about all we can narrow it down to. Oh, we forgot one conversion factor in here. We need to get minutes. So we need 1 hour is 60 minutes. And we can narrow that down to 1. So we end up with 2 times 5, which is 10 drops per minute. Okay, makes that a little bit clearer. Okay, let's skip down and do number 2 so we can practice a little bit more. Okay, we're looking for volume per hour. So That means we're looking for milliliters per hour. Okay, we have 100 mLs and we're putting 40,000 units. And we want it to run at 4,000 units per hour. So this will go into here and it'll go here 10 times. 10 will go into the 100 10 times. So all we have left is 10 milliliters per hour. And our drops per minute is going to end up being 10 drops per minute because we have that 60 minutes canceling out the 60 drops per minute. We have our 100 mLs over 40,000 units, 4,000 units per hour times 1 hour over 60 minutes. And now the 60 drops per ml. So we go there, we can go here 10 times, go once, 10, this will cancel out, and we end up with multiplying across 10 drops per ml, per minute. Okay, these are pretty self-explanatory. Let's go do one more. Where we're figuring out I thought there was one problem here to work backwards. Maybe not. Anyway, you got the general idea of, okay, here's one. It's just a little different. We're looking in milligrams right now. So we're going to have aminophylline. Our volume per hour is milliliters per hour. And we have aminophylline 250 milligrams in 250 mLs. So we want the 250 mLs, 250 milligrams, and we want it to run at 10 milligrams per hour. That's all you need for that part. This will go here, one, you can cross cancel, and it'll be 10 milliliters per hour. Okay, it looks a lot harder than it really is. However, it's still the same. Whoops, don't want that. Okay, so you can see that these are pretty self-explanatory. If you have any questions, let me know. We'll go on to our next study guide.